So this week's lesson is the fourth lesson from Unit 9 on antiderivatives. And we're going to cover something here called the definite integral. There it is, definite integral. I kind of hinted toward this last class in the last example. So what you see here is an integral, but notice that in the limits of the integral, we have numbers. We have a and b, or parameters. So these constants are going to be numbers that are given to you in most questions. And this calculation here ultimately has a geometric interpretation, which is the area under a curve. So what I'd like to do with you now is walk through as many examples as we can in the first hour, and in the second hour, or maybe in the first hour, depending on our pace, also consider some application questions. So you do have an assignment / quiz today at 10 o'clock. And the good news is all the stuff that we're doing in class anyway, it helps you for that. So you're good to go in terms of this week's lesson, and also we're doing a final lesson here before your test next week. That's it. So let's take a look at this first question. I'll go slow for the first couple, and then I might pick it up a little bit, depending on the quality or difficulty of the question. So we left off with 68. I'm going to start at 69 now. So we have here what's called a definite. See the word definite? That means that we have numbers in the limits of the integral of 6x squared, and it's from 1 to 3. The way that you say it from the bottom to the top. So you say in English, from 1 to 3. That's how you should say it, okay? If you want to say the whole thing out loud, it's the integral from 1 to 3 of 6x squared. That's how you say it. You can say the dx as well, but sometimes mathematicians don't bother saying it because the quantity in the integral, which is called the integrand, is what you really care about. Let's get this thing rolling here. So how do you do this? Well, it's actually very straightforward. The first thing you need to do is get me the antiderivative of that. So this lesson, I'm not gonna spend too much time on finding antiderivatives. I'm just gonna kind of give you the antiderivative, but I will do the early ones a little bit extra because maybe you're rusty at 8 o'clock in the morning. So in this case, the antiderivative of 6x squared is 6x 3 over 3. Plus c. Does that simplify? Of course it does. So that's 2x cubed plus c. So that's the process so far has been really just finding the antiderivative. Now we're going to deal with these limits. So the way that you deal with the limits is you take the quantity here, which is the antiderivative, and you draw a line here, and then you put 1 and 3. So this line here is an operator in math. It's you can think of it as an evaluation. By evaluation, I mean plugging in numbers. So what you do is you're going to plug in, and I'm sorry for the childish words here, you're going to plug in the numbers 1 and 3. But you're going to plug in the upper limit first. So you're going to have 2 times 3 cubed plus c. And then you're going to subtract, and you're always going to subtract the other limit being substituted into that expression. Okay, any comments? Any comments here? What do you think? So it's always b minus a, yes. So if we go to the formula, it's right here, okay? That's a good comment, Jai. There's the formula, see? You always put in b, and then you always put in a second. First b and then a, and it's always a minus sign. And capital F here is the antiderivative. So it's always of that strategy. So an immediate question arises here. Do I really need to write the c? What do you think, people? Do we need to write the c here? What happens to the c on the next step? Does everybody see that? Let me know in the chat. I want to see some yeses. Do you all see that the C cancels? Okay. So immediately, right off the bat, people, thank you. Right off the bat, for definite integrals, a lot of times you don't have to write it. Most people don't write it, although I don't want to mislead you. It's not proper to not write it, but if you don't write it, it's cool. What I did as a student often is I would write it right here. I would write the C here, and then I would just cross it right out like that. Like I wouldn't bother with it. So in any case, the C is here. What's the final answer here? Can someone give me the answer? Is it 52? Confirm? Very good. So what does this mean physically? This here we can interpret as an area. Don't worry, you don't have to graph anything in this class today. That's a parabola. Excuse me. It's y equals 6x squared. And what you just did was, from 1 to 3, you just found this area. That's what you just did, people. We computed the area from 1 to 3. So we're going to go through this process, and I went really slow on this first example, but through that patient first iteration, I hope that you have a solid foundation on how to do these questions. The only difference between this question and future questions is the level of difficulty of the antiderivative, in all honesty, at least for the first wave of questions. In this case, what is the antiderivative of x to the 3? I'm going to be a little bit aggressive on this stuff, so can someone in the chat just fire off the antiderivative? What's the antiderivative of x to the 3? Thank you, Jai. And everybody else, feel free to jump in there. I'm only seeing 4 or 5 names right now in the yeses and the nos, so I appreciate that, everybody. But I want to see more people. There's 27 of us. Half of us are probably drinking coffee right now. Anyway, notice I didn't write the C here. Honestly, it was unconscious. I didn't even think that I wasn't doing it. Like I was like, after I wrote this, I was like, oh crap, I didn't write the C down. But you know what? It's just a natural reaction after doing a lot of these. And as the more you get more practice, you won't write the C either because you'll be like, I don't need it anyway. Now, we're going to plug in a 1. And then we're going to always subtract. This is always subtracting. And then you're going to plug in a 0. There will be people in this audience that will be able to do all of this in their head. I know there are people in this crowd that can do that in their head. Final answer, can someone confirm? Quarter? Thank you. Okay. I'll keep that on the side tab, nice and big. So if anybody arrived late, they can take a look there. Again, the difference between this question and the next questions, I'm missing a slide page. Uh-oh. Okay, I'm actually missing one of the questions. Let me insert a page. That's weird. I'll just write it by hand, okay? So we're doing example 71 now. So we're doing the integral of 0 to 1, x to the n dx, and n is greater than or equal to 1. So what I'm really doing here for you is making a formula. Because n is greater than or equal to 1, you know ln x, that thing, we're not going to have it here because it's bigger than 1 or equal to 1. So this will be x to the n plus 1 over n plus 1 from 0 to 1. And through a little bit of practice, you can plug in 1 into both of those expressions. You'll have 1 to the n plus 1 over n plus 1 minus 0. Oops. To the n plus 1 over n plus 1. What's the final answer here? Someone let me know in the chat. Someone else? Right now I'm just seeing Nikita, Gianluca, Amir, Sean, Jai. Anybody else? Any brave people out there want to throw a number in there? What does this equal? Thank you, Ravindra. Clutch performance, my friend. Clutch performance. Okay, so that's another one in the down the pipeline there. It's on the side tab if you're looking over here. I'll just try to keep it up a little bit. So let's go to question 72. So question 72, let's do this one a little bit slower. That previous one is just a generalization of a power function. But now, so you could have that like as a, if you make a cheat sheet or like a study sheet for your test, this is a sweet one to have. This is a very, but the thing is though, honestly, it's from 0 to 1. Is it always from 0 to 1? No. So you could probably make it from A to B if you like and make a formula for that. Or you can just do it each time manually because it's probably just as valuable to practice that. So in this case, the antiderivative of x to the 4 is x to the 5. And what about the pi? Well, the pi is just a constant. So it's just a coefficient, so it just carries over as per usual. Notice I didn't write a c here. For those that are arriving, I didn't write a c here because the c is going to cancel out anyway. So now we just plug in 1 and -1. So we have that. And this is always minus. I'm going to put a nice big chunky minus sign there so you know that it's always minus. At this point though, I'm going to let you, I'm going to make you sweat it out a little bit. And I'm just going to say the answer here is 2 pi over 5. I know you're capable of doing that. It might take you 30 seconds or 20 seconds. It might take you 2 seconds. It might be automatic for some of you. But anyway, that's the answer that I got. Can someone confirm that, please? Yes, anybody that's spoken already can confirm. It doesn't have to be someone new this time.
Yeah.
Thank you. Ethan. Good. Anthony. Is that Anthony?
Yeah.
Okay. Well done. Okay, so what's the difference between 72 and 73? More terms. That's all it comes down to is more terms. So I'm just going to give you a second to read that and kind of think about what you want to do there. And then we'll talk business. Just so you know, just so everybody's clear, today's class is going to be 2 hours. But once we get to question 80, we've completed the lesson for Unit 9, Part 4. After that, the remaining questions in the booklet are actually review questions. So that's what I was saying earlier is we're going to get through what we need to get through. And then after question 80, it's extra practice. And I'm just going to stick around for how much time we have before your assignment and do as many as we can. So if you're like, is there a light at the end of the tunnel? Yeah, there is. Question 80. Now, along the way, some of those questions before question 80, including question 80, are a little bit nasty in terms of how much work you have to do. But for now, these ones are not too bad. Can someone in the chat give us the antiderivative for this? Simplified. What is the antiderivative of 73? Simplified, please. You can do it in separate steps if you need, but so what's the antiderivative of x to the 5? It's so quiet. What's the antiderivative of x to the 5? In the chat, let's go. We got this. Dogan, that is correct, I think. I'm gonna write the extra step. I have a feeling that some people are kind of worried. Yeah, Dogan's answer is correct, but I'm gonna go the extra step here because I have a suspicion some people are worried. So the antiderivative of x to the 5 is x to the 6 over 6. The antiderivative of x to the 3, this x to the 3 here is x to the 4 over 4, which simplifies to exactly what's in the chat there. So that's half x to the 6 minus half x to the 4. we're not done setting up the answer, people. I'm just writing down the antiderivative. This is a definite integral. So when you have those numbers there, then you got to put this line and put 1 and 2. And that just means that you're going to be substituting in some numbers shortly. So I'll be very gentle again on this one. I just saw that we got 5 more people in. So what does this thing here mean? What it means is that you plug in the 2 into this expression, and then you plug in the 1 for x into that expression, and you subtract the 2 answers. So let's see if I can fit it in my template here. So you're going to have half 2 to the 6 minus half 2 to the 4, and then minus half 1 to the 6 minus half 1 to the 4. Do you see that? You plug in you plug in 2, and that's why you see the 2 here for x, and then you plug in 1 for x. Nikita, you're ahead of me by a mile. Good job. I got 24 as well. So from this point, if you don't mind, everybody, this stuff here is just numbers. So that's arithmetic, and Nikita's answer is correct. It's 24. It's good work. Good work. So your test is next week. What's the part that you don't understand, Ethan? Help me out. Why do you put 2 in both of the first part? Okay, no. Let's talk here. You're going to put 2 into this whole thing. And you're asking, why do you do that? Because that's the formula. It's okay. Some people are wondering. Excuse me. So that's the formula right there. You see, you have the antiderivative, which is uppercase F, and then you plug in B and A into the antiderivative. In this case, this is not for Ethan, this is for everybody. In this case, the antiderivative is 2 terms, so you plug in the upper limit into both terms. And if this thing was 50 terms, you plug it into all 50. And yeah, it's going to be a lot of writing. It's going to suck. I'm sorry. I've been there. I've been there as a student, and I know it sucks, but it is what it is. So you got to do what you got to do, right? So the antiderivative of 2x, that one is super easy. That's x squared. That's just almost memorized for most people now. And then the antiderivative of x to the 2 is x to the 3 over 3. So this part of what I'm doing is what I was doing with you 3 weeks ago. Antiderivatives, right? This is stuff that I did with you the first day of the semester. Then you put 2 and 3. And now you're going to plug in 3, the upper limit, into both terms. So you're going to get 3 squared, and then you're going to get 3 cubed over 3. That's half of it. That's only half of what you have to do. I'll put square brackets here, nice, robust brackets there. Now I'm going to put in 2 into both terms. So we'll have 2 cubed. Sorry, 2 squared, I apologize. That's a squared. Minus 2 cubed over 3. I'm going to work it out sideways so that you can see both answers on the screen. So the first bracket, what does this first bracket turn into? Correct. And what does the second bracket turn into? I got 4/3. So yeah, that's right. So you are correct. Thank you, Nikita. Thank you, Jai. I mean, Jai agrees with me, so I'm thanking him for agreeing anyway. So that's pretty funny. So can we agree that it's negative 4/3? Negative 4/3. Thank you, Gianluca. So wait a second. I said to you that these things here, this represents an area. Didn't I tell you that it represents an area? Who remembers I said that represents an area? I said that at the beginning of class. Okay, let's draw this thing. I'm gonna do a very bad drawing here, so just don't hurt my feelings too much. So the x-intercepts are 0 and 2. I'm digging back into the brain cells, those neurons from like grade 10 to do this. So it's a parabola. Honestly, I need to learn how to draw a parabola. I was pretty good at drawing them anyway, but there you go. So what are we doing here? Here's 3. Let me draw 3 nice and close. Okay, please don't chirp at me too much. This is not the scale. But what we just did was we found this area. We found the area from 2 to 3. So we found this area in here. This is not a triangle. But what I do notice is that the area, you notice how the area is below the x-axis? See how it's underneath the x-axis? When you have areas that are below the x-axis, they are negative areas. And if you were to find this area here, just hypothetically, that would be a positive area. So areas under curves, or areas between the curve, this graph here, and the x-axis, can be interpreted as positive or negative depending on if they're above or below the axis. So that's why this answer is negative. No one's going to ask you to graph stuff in this on a test, although you may see a graph on your test given to you. So be aware of that. You might have to interpret a graph because these are very visual type scenarios. Like, anyway, you might I'm not gonna say that you have to because there are ways to get around questions without graphing. Anybody have any questions about 74? Let me know in the chat. Do you have any questions about question 74 before we proceed? Thank you, Dogan. So I think it would be very useful as you're doing these questions or you're practicing in the homework. It actually comes in handy to take this thing here and plot it. So if you use Desmos, for example, if you've seen me draw things on the web page Desmos, you can plot this and actually visualize the area. And there's many other programs out there that'll allow you to do that as well. 75. Again, another question that's good practice for you for today's quiz or / assignment. In this case, it's not guess and check because you can just expand that. So that's just x to the 4 minus x. So before I even venture off and actually find the antiderivative, I should just quickly clean it up a little bit like that, because that's easy to do now. These antiderivatives are fairly easy. Yeah. So I'm going to go back to Ravindra's question, okay? Ravindra's question is a very solid question. So hypothetically, no, I understand exactly what you said. It's a good question. So the question, or I'll just say it as a comment mostly. Ravindra's comment is this. If I was to find the area from 1 to 3, then yeah, there would be a positive number and a negative number. They wouldn't cancel each other out fully because I don't know if the green and the red are exactly the same. I don't think they're exactly the same, but you're definitely right. Like there would be an offset. If you don't mind, Ravindra, I'm just gonna make up some numbers there, okay? I'm gonna make up a number. I'm gonna say that this area, for example, is 5/3. I'm just making that up right now, okay? And then this area is negative 4/3. So then if you were to go from 1 to 3, the area would be what? 5/3 minus 4/3, that's 1/3. So that'd be the total area. So there'd be like an offset of a positive and a negative area. Does that make sense? It won't be 9 over 3 because areas can be negative, okay? Sorry, let me say it better. This thing here is interpreted as an area, and with integrals, areas can be negative. If a question, though, just to be consistent with what you're saying, if the question said find the area, this question does not say find the area. But if the question said find the area, you could interpret it as both as positive. But I'm not gonna play those games with you in this class. That's something that I would deal with in a more advanced mathematics course. Okay. For this, you don't have to worry about writing the area. You don't have to you don't have to worry about if it's positive or negative in terms of canceling out. Your goal in this context is to just be able to evaluate this. That's all I want you to really take away from it so far today, okay? You're welcome. But your question is very, very deep. It's a very, very strong question. Very good question. Okay, over here, we can find the antiderivatives of these guys. So that's x to the 5 over 5. And you'll have to, if you're like, wait, if you think I'm going fast here, I really believe that you need to practice more because this stuff here is like introductory. I know that your test is next week, and I'm pretty sure that on your test, I think there's 20 questions or so. I forget the exact number. But there might be 2 or 3 that are this easy. And I mean easy, I mean just one term. Just one term, okay? Like easy peasy. So in this case, anyway, you have that. And now what you're going to do is plug in the upper limit and then the lower limit. So watch what I do this time. I'm going to have some fun with you. Okay? There's my template. Because it is a template, right? So if it's a template, why don't I just recycle it? This is how I want you to think about it. It's a template, okay, people? And in that template, you're going to plug in the 2 limits. So in this case, you put 2 here because 2 is the upper limit. And the lower limit is -1. And you're going to get that. And then I'm gonna eat because I got my friend Nikita who's already done the work for me. I also got that as well. 5.1. That's excellent. Now if you're like, wait a second, why are you writing a decimal? It's 5.1, I'm pretty sure. I have my solution manual too, Ethan. We'll double check it anyway. Let's go through it slowly, okay? No, don't cast away your answer that badly. This is 32 over 5 minus 2 minus 1 over 5 minus half. Okay, yeah. If you don't mind, I'm gonna spare myself the embarrassment because it's too early in the morning for me to do fractions. Yeah, I'll admit it. Okay. I'm relying on everybody in the chat to do the quality control. So anyway, 76. Let's just go to the function notation for a second here. So we have x. We can rewrite the integrand. This thing here is f of x. That's f of x. So that's 8. And then we have 4x plus 1 to the negative half. So for this question, some of you will prefer to use what's called the substitution method. I'm going to use guess and check for this, okay? So I'm going to use guess and check here. And then, and I know that it's not the way that some people like, but this is the way that I've been doing it because it's how the book does it as well. So I'm going to guess the antiderivative. is going to be this thing here, and then you add 1 to the exponent. If you add 1, you get positive a half, and put a C. And then we're going to check. So we'll have here half, but the 4 and the 2 we cancel out to get a 2. So when you look at it, what we're trying to see, we want this thing here to look the same as this. Someone comment in the chat, are they close? Yeah, you just got to put a 4. Thank you very much. So if I put a 4 here, I adapt it. So this is my antiderivative. This is the final answer for the antiderivative right there. Then this becomes a 4, and this becomes a 4, which is 8. And I'm just going to put a happy face there, because that's 8 right there as well. And I'll just double color it. Okay. So a lot of danger in doing the guess and check. A lot of not the method itself, it's just it's a harder question. I'm going to take that all there and just kind of put it aside. Because now we can actually pursue the answer to the question. So now we can actually do the question. So this is going to equal 4. It's this thing right here. This is a square root. So I'm going to write 4 root 4x plus 1 plus c from 2 to 6. As I mentioned earlier, you don't have to write the c because the c is going to cancel anyway. So I'm just going to cross the c out right away because we don't need it. And now what you're going to do is plug in 6 into this expression. So we have 4 times 25, because 4 times 6 plus 1 is 25. And then you're going to plug in 2. So you're going to have 4 root 9. Which actually cleans up really nice. Can someone confirm that they got the same answer? Anybody else get 8? Awesome. Perfect squares. Yeah, we got lucky. Ayo, we got lucky. I want to show you something for a second. Your test review is right here. There's your test, okay, people? So you see the test is 25 questions, and you have 2 hours. One thing I want to tell you, I gave a little speech about the test already. So the announcement is on Blackboard. You can find it under announcements. But what I do want to say, though, is this. Where would this question fit in to the test? Just so you get an idea. I would consider this question to be like a medium difficulty. Oh gosh, Ethan, if you need a job as a TA, I might hire you as my TA, because exactly where it should be. So Ethan is absolutely spot on. This question would be a definite integral of medium difficulty. Does that make sense, people? It's a definite integral of medium difficulty. And what would it, look at questions 15 and 16. Says he definite integral, easy medium? Well, that would be like the questions prior to this. Every question prior to this is more of an easy to medium, because if the antiderivative is easy to find, which every single one prior to this should be for you, they're not hard to do. They're just power rules, right? These are just power rules. So those types of questions would be categorized as 15 to 16. And obviously here toward the end of the test, I just say mystery because I'm not going to spoon feed you. And you can definitely see that there's some other ones where I don't tell you what it is. There's many reasons for this, of which include this review package applies to the other section as well, and your section and the other section won't have the same test. That's why there's a disclaimer at the bottom of that review, of that summary there. It says that summary that you see there is subject to small modifications. So what you see there, I might add or remove a question. Okay? Sorry, people. I'll leave it there for a second. Yeah, so what you see in that review there, I might add or remove a question, just so you know. So when you write the test next week, if whatever it said there, 24 questions, whatever it said, if your test is 23 or 25 or 26, it is what it is. Like I haven't carved it in stone. I also haven't taught you this week's class, right? So of course, what we do this week could impact your test a little bit. Like if I find that after teaching you this, maybe it was too easy or too hard, I might adapt the test a little bit. Most likely not, though. I do have enough experience to remember how to make good tests, but I'm just saying, like, don't take it as gospel that it's 100% what it is. So question 77 is a very long question. I'd like to go through it now before the break, and then I'll give you a break after, because I like to just deal with this question first. May I switch over to question number 77 now? Does anybody need 76 still? Don't be shy to ask. I don't mind. I'll have it here on the side anyway, and I will post these answers on Blackboard soon. Usually, as you're writing your in-class assignment / quiz, that's when I toss in the notes to Blackboard. So for this one here, this one is very involved because it's guess and check twice. So I'm gonna just state what the antiderivative is because that takes up most of the question actually. That's how I would do this question. I would use guess and check for each of these. So for this one here and for this one here, I would do what I did in the previous question. I would do guess and check. Now, if you don't want to use guess and check, that's okay because you can use the substitution method if you're familiar with it. So for that, I'm just going to state what the antiderivative is. And then proceed from there, because the hard part of this question is the antiderivative. So in this case, the antiderivative, and if anybody can confirm this for me in the chat, that would be appreciated, because I am copying this from my solutions. As you know, all the solutions that you get for these booklets are my solutions, not a textbook solution. So I'm always open and aware that there could be mistakes and subject to scrutiny. Can someone confirm in the chat that they agree with these? You have time to still do this if you're still working on it, if you're trying it out first. You could write it like this if you want. Okay, I'm just double checking it again. I'm almost certain that this is correct. This is the antiderivative. So from here we can actually simplify and evaluate. Or I should say evaluate and simplify. So in this case, we have the antiderivative. So what we do is we just put equals. We copy this whole thing here. Yes, this entire ridiculously long expression. And we're going to evaluate this expression from -2 to 0. Like that. As you can see, I'm using the keyboard here because this one is really long to type otherwise. So we're going to plug in -2 into this. The C cancels, so I'm not going to write the C down. So what do you get if you plug in -2 here? Sorry, 0. Plug in 0. Thank you, Ethan. Yeah, if you plug in -2, that's the second one. That's my bad. That's my bad. So you're going to plug in here 0 first for x, and then you're going to plug in -2 in for x for both. And obviously, it's a lot of writing. This question is much longer than what I would ask on a test. If you're going to get guess and check on your test, which you will for sure, it wouldn't be this much. It would just be maybe one of these, not both, just one of them, okay? Because there's too much writing. So this question is definitely longer than what I would like to give on the test. As you noticed, even last semester, most test questions were kind of like 2-3 lines of writing each, maybe 4 lines for the hard questions. So in this case anyway, we have 2 brackets and we have to deal with them. So here we have this, which becomes 1/3, and then 4 to the 3 halves is 8. So that's 1/3 times 8. And then over here you have 1/4, and we have 8 to the 4/3, which is 16. Next line over here, as mentioned earlier, Ethan was correct. That's going to be 0. So it's 1/3 times 0 minus 1/4. And then here, unfortunately, this one is not too promising. It's 2 to the power of a fraction that does not produce a rational number. This is going to be like a cube root to a power of 4. It's going to be a decimal quantity. So I'm just going to write it as a decimal. Just that number there, I have the final answer. I'm just going to write the final answer because actually I'll write 2 steps more. It's a little bit annoying, but if you clean this up, and the exact answer is this, just so you know, it's -4/3 plus, and you can simplify the second one with a little bit of effort. It's going to be really annoying. I'll leave this for you to try on your own, but it's not very fun. I would accept the answer below though. -0.703. Anybody in the chat actually get that number? If you got that number, -0.703, and it was like that was it, and you're good, that's very impressive because this question is not fun. Oh, very good work, people. Yeah, even Nikita, even if you're close, like, what was your number? Do you remember what your number was there? 7, was it 0.7 something? Like you said, it was near that. Yeah. So you were in the right ballpark. Yeah, this number here, this 3 here, I don't know if it continues because a cube root is not a rational number, so I don't think the decimal will have a pattern. It shouldn't have a pattern. Anyway, people, it's 8:53. Let's take a break. So I'm gonna give you a nice healthy break. Let's take a break till 9:10. Okay, break till 9:10. Go get yourself a coffee. Sorry about the few minutes of delay beginning today. I apologize for the delay. My computer, it said I need to do a minor update. So I was like, okay. And then that minor update took 30 minutes. So yeah. Anyway, I'll see you back here in what? 16 minutes. Go take your break. Go eat something, get a coffee, whatever you need to do. Thanks. Oh, I see what you're saying, Ethan, about the 0.63. That's how you get the continued. Yes. We're going to do a few more questions, and this should wrap up the new material from the chapter. And then after that, we're going to do extra practice for however much time we have remaining until the end of today's class. And at 10 o'clock, the window will be open for you to write your in-class assignment, or called quiz on MyLab by default. So let's take a look here at question 78. I'd like you to just take a moment. If you want, you can try to figure what the graph of that looks like. And we'll talk about it momentarily. I'm just going to go into my lab for a second and make sure that the assignment is ready there, because this morning with the announcements tab missing, I kind of got worried that something's wrong with the platform. So I will join you in this example in about a minute. Okay, so hopefully you had time to read it. So it says here, find the area. Sorry, interpret this as an area. And that's very, very good. So the answer is going to be nice and elegant. Unfortunately, it's not going to be 0, but it will be nice. So you might have to dig back into your archives to remember that this is a circle. That's a circle with radius equal to 2. But if you solve for y, like that, and the center is 0, 0. You can't hear me. Oh. Can you hear me now?
I can hear you.
Okay, I'm not sure what's happening there, Sean, or who is it? Amir. Can you hear me, Amir? Okay. Yeah, it might be because I opened a separate browser. I was trying to do something on the back end on Blackboard. I was changing one of the settings. Anyway, this is the circle of center. Center is at the origin, and the radius is 2. So if you plot this on a grid, I'm not going to draw the grid here. I'm just going to draw that. Then the diagram is indeed what was mentioned. I think it was Ethan said it. It was a semicircle, and the radius is 2. So this is geometrically what we can interpret this integral as. So this is equal to the area of a semicircle. So the area of a circle is pi r squared, but a semicircle would be half of that. And it's a semicircle with radius equal to 2. So the radius is 2, just put 2 there. So the answer is 2 pi. It's a nice question because there is an alternative way to do this. There are many alternatives to how to do this, but they all involve methodology that is beyond the scope of this course. As I mentioned to you at the beginning of the semester, integrals and antiderivatives, those techniques and methods that can be used to solve these, when possible that is, they can span more than an additional 1 or 2 courses. And I mentioned to you, in my experience in undergrad, I did at least 4 courses that were purely about finding antiderivatives or solving for or dealing with integrals, and they got really, really advanced. So just anyway, it's a nice question because you can just use the geometry of the situation to figure it out. The worst case scenario is I might give you one of these on your test. That's the worst case scenario, okay? And this question does come from the book, so if you do go to the textbook, I'm sure that you can find more, and I'm pretty confident that I had recommended another one like this as well in the book. Let's go to question 79. So this question, it kind of ties back to what we did in the first couple of weeks, where we're reconstructing a function from its derivative. But ultimately, we can think of it as a different thing as well. We can think of it as finding out the cumulative amount of a quantity based on its derivative. In other words, if this is the derivative of r with respect to time, this over here, it just means r prime. Then if we actually do the following, we can integrate and find the total. So it says here, what is the revenue that can be expected in the next 10 years? So what we're going to do is we're going to add up. That's what that means. It means a total or a sum. As we saw this last week with areas and the tables, it means we're going to find the cumulative amount for this revenue rate. And that gives us the total revenue for the 10 years. So it amounts to the following calculation. No doubt, this is a very annoying question and would require something like guess and check to figure out. I think question 79 is the harder question compared to question 80. Question 80, the antiderivatives are easy to do. It's just that you might get confused with all the symbols. So in this case, we need to find the antiderivative of this expression. Now, if I continue to the next step, I'll write down what the antiderivative is here. I'm going to just tell you the answer for the antiderivative, and then on the side here, I'm going to show you how I got it. So for now, I'm just going to tell you the antiderivative. So I'm just looking at my answer key for this one, if you don't mind. These ones I don't like doing in my head, especially this early. So that's the antiderivative of this. The antiderivative of 20 is really easy. It's just 20t. So I'll discuss with you how I turn this into this. That's what I'm going to talk about briefly now on the side, because that's not an easy step, and I can respect that you have questions about that. So I'm just going to do that over here. I'll just pick a different pen here. So we have the following. I'm not focusing on the 20 because the 20 is easy. So if we had a derivative which was the following, f of t, sorry, then that would be 400 t squared t cubed plus 20 to the negative 2. I'm just copying what's in the integrand over here. I'm going to guess now that the antiderivative is the following. So that's negative 2. I'm going to guess that the antiderivative is just 1 degree higher on the exponent. And there is a c there, so we'll put it there. Although I don't have a c here because it cancels out anyway. Let's check. So if we check this, the derivative of this is going to be negative 1 t cubed plus 20 to the negative 2 times 3t squared. And if you clean that up, you get negative 3t squared you get that. Now remember, for those that are just, maybe they got a little bit confused here, you might have to come out and come back in, Ayo, because it's on the screen here. So let me unshare and reshare. Can other people see what I'm writing? Okay. Yeah. Yeah, Ayo, pop out and come back in, okay? So everything that I'm writing here in the black is just verifying for you this step. So this arrow in black here is all of the stuff here on the right. But we're not done yet because this has to match. Does this thing here look the same as this? Obviously not. So we need to do something to adjust our guess, which right here we can do that. That's going to be negative 400 over 3. That's what you need to put in front. So I'm just going to put negative 400 over 3 all the way down. And now it's the same, because this equals 400 t squared t cubed plus 20 to the negative 2. So as you can see, the lion's share of the difficulty with this question is in itself finding the antiderivative, which is why it's so important that you really work on the guess and check. So at this point, we have confirmed that this is indeed the antiderivative. This 20t is easy, so I'm just going to put an arrow there and put a happy face, because that's really easy to do. And now what you're going to do to finish the question is plug in 10 and 0. I think I'm going to run out of space writing this, so I'm actually going to just cheat, if you don't mind, for my answer key. And I apologize for that, but you don't want to see me writing this by hand, because I'm going to probably put you to sleep. That's straight from my answer key. As you can see, it's just a lot of plugging in. So what I did was, I'll just annotate it so it's clear. I put 10 in. See, there's 10. And then I put 0. There's 0. And then I clean it up and we're done. So eventually you're going to get 207. Now the question says that it's thousands of dollars per year. See that, thousands of dollars per year? So the final answer is going to be $207,000. Not that this is on your test specifically, but a question like this, I would say probably is like one of the hard questions on the test, strictly because of the amount of work that's needed for the antiderivative, the unit conversion at the end, the interpretation of a function involving a rate, or finding a cumulative amount of something. There's a lot of working parts here that make this question on the much tougher side. So if this question intimidates you, at least have some comfort in knowing that if it is on the test, it'd be one of the hard questions toward the end. Certainly not one of the easier or medium questions. So I have one more question to do with you. Hopefully it doesn't take too long, and then we can spend the rest of the time on the review. This question that we're about to do comes from fluid mechanics. And as many of you know or may know, my background is in aerospace, and specifically I have a strong background in fluid mechanics as well. So these are the kind of formulas that I was creating as a student in undergrad during my time taking all these fun and exciting math and physics courses. So let's take a look at question 80. So in this question, I'm not asking you to invent something or create a formula. In this question here, you have a volume of liquid flowing through a pipe of radius r. And depending on the property of the pipe and other factors, you can determine how much volume of fluid will go through that pipe. Now, if you're wondering, where does this come from? It comes from background in fluid mechanics. So, and to be frank with you, I'm not expecting you to be able to invent formulas from physics. However, on that note, let's say that some of you have an interest in pipe flow. Maybe that's something that along the way, even as a construction manager, maybe along the way somewhere, there is the need to understand a little bit about the physics of pipe flows. And then what happens is you go to some journal paper or textbook, and the formula that you need to understand to apply it to a real life situation looks like this. And you're like, what the heck does that mean? So this is where our course comes in, because you can take a look at this formula, and the last thing I want you to do is get scared. When you see this formula, I want you to see it through the lens of the mathematics that I've shown you. See this thing here? You know how to do that. That's an integral. And you see this thing here in yellow? That's another integral. So if you look at it through the lens of what we've been doing the past month, including today, if you can figure out those two, this one here in blue and this one here in yellow, then you're done. So that's what we're going to do right now. We're actually going to just apply that process of antiderivatives and the definite integral to this question. Let's take a look at the blue one. I'll just put a blue marker here so that you know we're talking about the blue one. So we have the integral from 0 to big R of r dr like that. If these letters scare you, this doesn't have to be r. It might as well be x, because it doesn't matter whatever the letter here is, it doesn't matter, because at the end you're just going to plug in numbers anyway. R here is a number. It's understood that you would know it eventually. So what's the antiderivative of x? It's x squared over 2, but here we don't have x, we have r. So just think of it as an x, and you should be okay. Do we put the c here? Well, I'm kind of lazy for that because it's a definite integral. I don't like to use the word lazy, but it's from experience that I know the c is going to cancel, so I don't bother. Now what you're going to do is you're going to plug in r and 0 into that expression. So you're going to get r squared over 2 minus 0 squared over 2, which after a little bit of effort, you get r squared over 2. So to conclude, the first integral, here the blue one, is this. So we're almost halfway done the question. Now let's do the yellow one. The yellow one looks a little bit scarier. We have the integral from 0 to r of r cubed dr. So I really want you to see this. Like if you're doing any research later in your life, and you're doing, if it's fluid mechanics or whatever concept it is, it could be something regarding management, or it could be regarding economics or whatever. You might encounter some weird looking formula like that. The last thing I want you to do is look at it and be like, oh my goodness, I have no clue what that means. You should be able to parse it, to just look at it piece by piece and say, oh, integral here, integral there. And then I hope that many of you understand and appreciate what I'm trying to say there. So the exercise here is that you're not intimidated by this formula, or any formula that you encounter later. If the antiderivative of r to the 3 is r to the 4 over 4, and we can plug in the two limits here. So we have the upper limit, which is r, and we have the lower limit, which is 0. So that gives us r to the 4 over 4. So that's the answer for the yellow part in the overall question. That's my fun time coloring. And now we're ready to go, my friends. We are so ready to go. Because we can go back to the main formula and just plug in what we need. I'll do it in black. So V equals K. V equals K, and then we have R squared. And then we have the quantity that's highlighted in blue, which is R squared over 2. Minus, we have the yellow quantity, which is R4 over 4. And we certainly have achieved the final answer as desired, because this stuff here is r to the 4 over 4. You can clean it up by hand on your own. You should get r to the 4 over 4. And that's the answer to the question. If this question, again, I'm not saying that it is or it isn't, but if this question was on your test, it'd be one of the harder questions at the end. So you kind of start to see how everything fits together regarding the test. We've covered everything that I need to show you to comfortably say that we've gone through antiderivatives, integrals for definite and indefinite form, and I think that you're ready to actually just get to write this test. Obviously, you have a week to study, but we'll see. Okay, so question 81. Let's do some review here. So we have x to the 4, that's x to the negative 4. We know that when this is a definite integral or an indefinite integral. In this case, it's indefinite, meaning that there's no numbers in the limits. So this kind of gets back to what we were doing in the past few weeks. So you're going to put the constant at the end. So that's x to the 5 over 5, and then you have x to the negative 3 over negative 3 plus c. So that's x to the 5 over 5, and then you have 1 over 3x cubed plus c. I'm not expecting you to be that quick, but if you are that quick, I don't think you're going to have much time to write the test. I mean, sorry, you're not going to have too much difficulty in terms of time writing the test. So this question would probably be easy to medium on a test. Let's go to 82. This one has a single term on the bottom, so you should chop it up. So that's 1 over x. I'll write it as exponents. That's x to the negative 1 minus x to the negative 2 plus x to the negative 3 minus x to the negative 4. And from there, you're just popping out these logarithms where necessary and the antiderivatives for power functions otherwise. So here you have x to the negative 1, which is ln x. That's the special one. And then you have this. You're going to take negative 2 and add 1 and get negative 1 over negative 1. You're going to take negative 3 and add 1, and you're going to get negative 2 over negative 2. Negative 4, you're going to add 1, and you get negative 3 over negative 3. Don't forget the c. And then clean up all of these negative signs on the denominator to wrap it up. It has a nice little pattern, but it's just another mess of terms that you can deal with individually. 83, use your fractions and exponent laws. It's on the side here, Ethan. Can you see it? Sorry, I know people that I've picked up the pace a little bit, but I'm trying to just do a little express for the review. Where does the x to the 4 go for in 82? What happens is, Asim, is I'm writing them all over x to the 4. So this is x to the negative 1/12. So this is the integral of x to the negative 1 over 12, which is going to become x to the, if you take negative 1/12 and you add 1, you get, that's 1/12. My apologies. That's 1/12. Then this is going to be 1/12 plus 1, which is 13 over 12. And then that's 12 over 13. What I called the checkerboard pattern from the past lectures. Okay, I'll pause for a minute there. I'll pause for 1 minute and then we'll do a few more. Okay, let's go through a couple more now. You're talking about the last week's quiz. Are the marks not visible? Can anybody see the marks on my lab from last week? Well, I'm not sure what to say. If you wrote the quiz, it should be there. I'll take a look before the quiz, but they should be there. I made them visible. If someone doesn't write the quiz, then their marks are not going to be there. I don't know. Did you write the quiz? I'm not sure. It's all documented there. Anyway, let's talk about it at the end of class. Oh, on Blackboard. Oh yeah, sorry. Yeah, no, Ayo, I think you did write the quiz. I'm not worried about that. Yeah, the marks for Blackboard, I haven't moved them over. I don't move them over until you write the test. I don't move the marks from my lab onto Blackboard until the test is done, because I need to make adjustments. But it is available on my lab. Thank you. If you go to my lab, you can find it there. Okay, I don't know about that. That's interesting. I'm not gonna put the recording of these extra practice questions because it's kind of like all over the place, and we did get sidetracked by my lab. But anyway, still practice. So here we have a definite integral. So just like one we've been doing today. So we have the integral from 1 to 8 of x to the 1/3 dx. I'll post these answers on Blackboard just as we finish today's class, as you're writing the quiz, okay? So you can take a look there for extra review. So the antiderivative of x to the 1/3 is x to the 4/3, and then we divide by 4/3 or multiply by 3/4. That checkerboard pattern that I always refer to. And then you plug in the limits of 1 and you put 8. So you put the 8 first, so you're going to have your 3/4, 8 to the 4/3, and you're going to subtract, and you always subtract there. That's why that minus sign is so large, and just want to emphasize that. So you get the following difference. So let's see what happens here. Okay, this thing here, this is 16. That's 16. So we have here 16 times 3/4, which is 48 over 4. And then you have, of course, this is just 1, so I'll cross that out. So I got an answer of 45 over 4. And definitely could do another one of these. So why don't we do 89? Let's do 89 because it's guess and check. Don't be scared of 90. 90 here, you see this stuff here? Just do those separately. So I'll give you a clue for 90, just because it's really, really quick if you do that. This thing here, if you evaluate it, you're going to get an answer of 2. And if you evaluate this here, you're going to get an answer of 7. And now the question is similar to a couple of them that we covered already today. So that's a happy face. It's still guess and check. It's guess and check, but at least it's not too bad. So that's my little hint there. Go back here now and let's do question 89. So in this case, we're going to do guess and check. So we have the integrand, which is x squared plus 1 to the -4. So we're going to guess, that's what the g stands for. We're going to guess the antiderivative, which will be x squared plus 1 to the -3, because we add 1 to the exponent. I'll put the c here even though it's definite later on. That's fine. Now we're going to check by finding the derivative. So that's -3 x squared plus 1 to the -2 times 2x. So that's -6x. That's a 6, sorry. X squared, whoops. I can't do subtraction today for some reason. That's -4 there. Okay. So I kind of did a little hiccup there at the end. But anyway, ultimately, this is the antiderivative right here. This is what our antiderivative is, because we're guessing the answer. Unfortunately, this guess is not good enough because this yellow thing should match that yellow thing. But they don't match because there's a number here of -6, which there isn't here. So we should preemptively put -1/6 in the integral. Let's do that in green. In the in the antiderivative. So I'll just put -1/6 there all the way down. And that'll settle everything up because these sixes and the minus signs cancel. So now these look the same, which gives us the ability now to actually answer the question. So we would have here the antiderivative of this, which is right here, -1/6 x squared plus 1 to the -3. Sorry, there's a lag on my stylus again. From 0 to 1. And at that point, I think you're ready to go with the answer. So I just noticed here that I need to make a correction in my solutions. I'll do that during your quiz. So I did find a mistake in my solution. So perhaps you can help me with the answer here. Can someone confirm that this antiderivative, they agree with it? Thank you, Sean. Now, help me out with this calculation here because I do need to fix my solution file. So this is going to be, if you put in 1, you're going to get 2 to the -3. And if you put in 0, you're going to get 0 to the -3. Sorry, 1 to the -3. So this is equal to 1/48 negative. And then over here, that's plus 1/6. So I got 7 out of 48. That's actually what I have in the solution, my solutions. I think I just typed something wrong I wrote something wrong elsewhere, like just a character mistake I typed.